So you can tell that I drew the short straw out of a lot of us tonight, as I'm the first non-semi/fully professional speaker. I am an academic, I'm a geneticist by training, and I have a particular interest in the genetics of Alzheimer's disease, but also in the roles that infidelity and promiscuity play in genetics. I also have an interest in the role of genetics in Alzheimer's disease. So just as a bit of introduction to myself, I just want to ask for a little bit of audience participation. So if anyone here has seen The Lion King before, if you could just stick up your hand for me.
See what?
The Lion King? The film? Okay, good for you. And if anyone remembers seeing it in the cinema when it originally came out, can you stick up your hand again? Excellent. So one of my favourite pastimes, because of my age, is actually reminding people of their own age, okay? So call me a little bit of a sadist, I might be, but I get great pleasure out of this. So for those people who put up their hands in answer to the second question, I hate to inform you that I am, to the day, exactly as old as The Lion King. The 15th of June 1994, The Lion King came out, and I was born. Sorry, I usually get it grown at that part. And so for those of you who are wondering how any of what I've said so far relates to the brief, or whether I even deigned to read the brief itself, I am getting to it. Those of you who know me slightly better are currently hoping, I'm praying to God, that I don't break out into my rendition of the Circle of Life, which is basically me standing like this, yelling unintelligible syllables that couldn't be more off key if I tried. However, my relationship with Lion King is actually a really nice segue into a discussion of Shakespeare. The science bit is coming later on. Because Hamlet is actually based quite, or The Lion King, rather, is actually based quite heavily. Definitely do that. It's actually based quite heavily on Hamlet. So the uncle, which in the case of The Lion King is Scar, kills the father, Mufasa. The son, Simba, goes off, sulks about it for a while, and then prompted by his father's ghost, comes back, has a date with the uncle, and takes over the kingdom. He doesn't die in The Lion King. I think that might be a little bit too sad. It's sad enough with Mufasa dying. However, the key differences between the two representations of The Lion King and Hamlet, other than the fact that one is a musical with singing animals, is the key role that Gertrude, Hamlet's mother, plays in the play. So a lot of people see her as an adulteress. She co-conspires with Claudius to kill Hamlet Sr. And put Claudius on the throne. And where all of the science comes into this is, as I was saying, a very tenuous link, I'll admit, but I like studying infidelity and promiscuity in genetics. So I admit to not being the best researcher in the world. Absolutely not. I've been at it for a very short amount of time, and within the first 2 weeks I had my supervisor so badgered with questions and problems that he actually started physically flinching every time I called his name. However, I was not the person in my lab to put tin foil in the microwave, so all in all I'm fairly happy with how it took so far. That was a bad day for that person. Oh, someone's just fallen to glass. At least they're down the back. So what I look at is promiscuity across all of genetics, but specifically looking at protein-protein interactions. So two proteins get together, they have a bit of a night out, have a great time, and then go their separate ways when their function is complete. So usually proteins have a very specific partner that they get together very often. But what I'm doing is I'm basically acting as a private investigator. I stalk the protein, I follow them around, and when they're getting together with a partner other than their designated one, I capture that one. And that's what I find really interesting. But more so on a general scale as well, promiscuity and infidelity in genetics is actually very relevant and crops up more so than you might actually think. So in terms of the replication of DNA, if we think of the DNA replication as the Gertrude of Hamlet, that's a crowbar in there somewhere, of the Gertrude of Hamlet, who usually picks Hamlet Sr. to insert into the new string of DNA when it's creating it. Bear with me. Sometimes picks Claudius, and by doing so introduces a mutation into the DNA. It's interesting to see how that infidelity can actually have a negative effect or a positive effect on the function of that gene. Kind of like how a comma put from one point to another point in a sentence completely changes the meaning. So for example, girlfriend not getting any better, come home soon, is worlds of difference away from girlfriend not getting any better, come home soon. Just one second. So arguably more interesting than looking at it on a microscopic scale, so looking at how infidelity in DNA replication has interesting effects in terms of the evolution of organisms, is looking at how the promiscuous behavior of different animals is defined by their genes. So in terms of this, you have the voles, right? So the voles are effectively the shorter, cuter cousin of the mouse, or so my younger sister described it. I personally think that the voles are a very fitting way to look at promiscuity, as the word vole is actually an anagram of love. But voles are 99%, or two species of voles rather, are 99% identical to each other, but one is monogamous, so one mates for life, and the other is polygamous and has multiple sexual partners over the course of its lifetime. I think all the guys in the room are like, I know which of those I want to be. But it's really interesting that the entire difference between the two behaviors is down to the number of receptors for a particular hormone in the reward circuitry of the brain. So this hormone is called oxytocin, or the cuddle hormone, which is probably the best name for a hormone I've ever heard. But the numbers of receptors define how likely they are to be monogamous or polygamous. So what I think is really interesting is the effects this might have on other monogamous species. So if you're feeling particularly brave and you're really stuck for a comeback, you could theoretically blame your unfaithfulness not on your own indiscretions, but on your genetic makeup. Okay? However, I will accept no liability for any damage done to your person if you choose to do so. And just to sum up then, I think it's very interesting to consider that if Gertrude might have had a very slightly different genetic makeup, she might have been more inclined not to cheat on Hamlet Sr. with Claudius, thus not giving Shakespeare the inspiration he needed to write Hamlet. Without Hamlet, we would have no Lion King, and without the Lion King, I wouldn't have a chance to practice my cycle of life.